Have you been looking for a solution to manage multiple workspaces using Terraform? Or even wanted a solution where you don't have to manage the state files? Terraform Cloud is a SaaS solution for you. Olaf and I will be talking about Terraform Cloud, some features, and demoing how to create an environment-based workspaces. If you like this kind of content, please like and subscribe. If you have any questions, please leave a comment on the video.
I've used workspaces both on-prem in the OSS Terraform CLI, as well as within Terraform Enterprise, which of course shares its features with Terraform Cloud for the most part. I can tell you from that experience that while workspaces are enabled for all levels of use within the Terraform ecosystem, the automation in place for cloud and enterprise really bring workspaces online. My use of workspaces is typically limited to some basic things like testing or environmental differences. As you'll see with cloud, workspaces are the basic building blocks of the IAC environment.
Right. So the benefits of Terraform Cloud include cross-platform state management. You can easily version control different workspaces and create like separate environments, like a dev, a QA, a prod. That's mainly how I've been using it. You can access other workspaces, remote workspaces, and create triggers to run if the state has changed in a different workspace. So if you want to do in order implementations, you start with one workspace and then run the next three if you need them. And state management isn't dependent on individual cloud resources. The negatives of Terraform Cloud mainly are around the pricing structure, and we'll go over the different tiers real quick. There's the free tier. Like I said, it includes state management, remote operations, and private module registry. The team and governance tier includes the free tier, has team management, Sentinel policy as code, run tasks, and additional concurrency. The free tier, you get one runner, which is generally okay with what I've been doing, but there's been times where it's been nice to have multiple, because when you do a change and you commit it, the step includes like kind of like a speculative build. And if you've made a big change, you have to wait for all the speculative builds to run. And then you do your pull request. And then you watch Terraform Cloud turn around and re-plan all those steps. That's the time. Currency has been really useful. Business includes teams and governance, which is the tier before, drift detection, single sign-on, audit logs, self-hosted agents, and custom concurrency.
Yeah, and I did some quick calculations on that from pricing on the website. That said, like the features and cost doesn't necessarily, if we're comparing against enterprise, we're not necessarily considering the value of local options. So when we run enterprise, and we can talk about that in a new video if people would like to hear about that. But in enterprise, you have a lot of options because you can run it within your own four walls. And for some enterprises, that's obviously just required.
Okay. The other, I say negative, I just like to do this warning every once in a while because I might have done it myself. You can use a beauty of Terraform Cloud is you can use Terraform Cloud. You can use Terraform resources to build out your environments. So you can use Terraform Cloud resources to build out your Terraform Cloud like run. So if you want to workspaces, if you want to change the name of your workspaces and you change all the names of them and you do an apply, it doesn't think, oh, look, your state file that you had in your old workspace needs migrated. It just destroys the old workspace and rebuilds it. So you have to be careful once you've built out your workspaces if you make any workspace naming changes, kind of like any other resource name change, that you could destroy your workspace and all of the state file stuff that goes with it. So,
Yeah, that's kind of interesting, and I that's probably the case because most people aren't thinking about this as simply as just renaming a workspace, but in reality, that workspace name uh, identifies the state file that where
mhm,
your state's actually being set. So once that change, if you modify state file, then all bets are off. I suspect there are ways that they might be able to get around that. Perhaps it's intentional as well, a way to destroy and renew if necessary. I ran into an issue as well, and I've since resolved this, but I just thought I would bring it up. So I ran into an issue with Git that at the time I didn't dig into, but it may be worth mentioning anyway. I tried to use a Git submodule within my Git project, not a Terraform module. I'm talking about VCS submodules. Anyway, Cloud threw an error early saying it couldn't find the symbolic link target. I saw in the provider docs later and within the UI that there's a flag for VCS that tells it to fetch submodules. So I missed that then, but then later turned it on. And but at that time, it was kind of easy for me just to remove submodules, so I never went
mhm.
back and tested it.
Right. I could see that would be challenging. Like it's there always seems to be more kind of like, oh well, there's this provider that does that too. Um, so I kind of want to show the demo of Terraform Cloud. We're going to do
Okay.
some uh, skipping through on the initial setup. Uh, I'll describe what I've done, but I'll tell you where you can find out more info. First, if you want to get started with Terraform Cloud, you need a Terraform Cloud account. It's free. You need to install Terraform locally on your computer. We have a previous video that shows you how to do that. You need IDE, like some sort of like VS Code, PyCharm, Notepad, I don't care. Like we have another video that talks about that. Terraform Cloud is available at app.terraform.io. When I set up my setup, I wanted to connect my GitHub to Terraform Cloud. So the thought is, I've got my repo of creating a workspace, and then it's going to be deploying my app services that I've used in several other videos. So I needed to set up GitHub OAuth. Once you've created your Terraform Cloud account, you can get the Terraform Cloud token. And then so I could connect to Azure, I needed to create a service principal. I think we have a few videos talking about how to do that. It's a pretty easy process. One thing I wanted to cover is there are the Terraform Cloud VCS providers. You can use github.com, GitHub Enterprise, gitlab.com, GitLab, EENCE, Bitbucket Cloud, Bitbucket Server, Azure DevOps Server, Azure DevOps Services.
The list goes
So,
on and on.
and on and on. Yeah, it's not terrible to set it up. So starting off, I want to show off how I just created a list of environments. So, defined it here. You can substitute using configs or whatever you want to do. But I just created an environment for a dev, a QA, and a prod. After that, I also set a Terraform Cloud environment so that I could have like a short reference point. And it's basically the same. I'm doing a for each, and you'll see this for each everywhere. Now I'm looping off this environment variable so that I can have a dev, a QA, a prod, and then setting that value here. I'm creating the organization name or organization email. This is part of the original setup. And then passing in my OAuth client ID, client secret, and subscription ID, all these variables that are all secrets, I'm just going to pass into it. I have it in my secrets.auto TF bars. This is part of the original setup. And then also to make this run for Azure, I needed to set these are the TFE environment specific variables. So this will be part of the workspace. And I'm creating the ARM client ID. So I'm basically passing in the variables so that each of the workspaces can access Azure and setting it as an environment variable, setting a description here, and then passing in the different names. Okay. After that, I create an organization. That's so weird. Sorry. All right. So I create the organization. This is the resource to create the overall organization. I'm just passing in the name and the email. And then the most important part here is creating the workspace. So as I was saying earlier, the nice thing about Terraform Cloud is that you can use Terraform resources to build out your Terraform Cloud environment. So even that is controlled by your repo. You can do PRs. You can do all the things. So in here, this is the Terraform Cloud resource workspace. And I did a test in there for the name because it doesn't matter. But this loops through each of the different environments. It's using data resources is what I've called it. And then I've added the for each environment variable here. So this tagged with the different names. So I should have 3 of them. It's being put into the TFE organization that I've created. Now this is interesting because this is the working directory. This points to a different spot in my code. So for instance, Azure Terraform data resources points to here, which then is what is going to be, this is what it's looking for to run my Terraform that I'm going to be running in Azure. This defines on the workspace level what the repo I'm going to be using is that I've already configured globally, but it needs to know too. So I've got my personal repo here, and then I've created a token ID to pass in for that. So to kind of go over this little piece a little bit more, this working directory, in my working directory, as we've done before, it is basically pulling down the name of the resource group, creating the app service plan, creating an app service, and that's all that piece does.
So yeah, and I see what you're saying. So then this piece of Terraform code actually generates the surround, if you will. It creates the workspaces and uploads the code that you expect to actually execute within that workspace for each of them.
Yeah, it basically says go inside the repo, go look at the location. So like I have it pointed to this spot within my repo, data resources. Yep,
Yeah,
right
and
there.
so that's an important designation that you're pointing out. Then it's when you specify a working directory, it's effectively looking at local relative working directory.
Yes, that defining this part, the local spots can be really tricky at times. Okay, so let's let me show you how the workspaces are created. So you can do a Terraform command. I'm in the workspaces directory. We're not actually in the data resources directory. We're currently in workspaces here. And let me make this a little bigger. So as I did the plan, it shows all the different variables being created. all of the variables. So because of this, the for each loop, right? So each of the variables are being reused for each thing. And I will be changing my OAuth token ID. Apparently it's showing it. Okay, so here's that workspace that I was talking about before, right? So this is creating the QA version of the test workspace. And shows data, resources, QA, and there'll be one for each of the different environments.
Right, because you named them for each environment. Cool.
So I'll do a Terraform Cloud.
So what's interesting to me here is that you are still using the Terraform CLI locally, because with this you are influencing the creation of workspaces that you can later point to from Terraform Cloud.
Yeah. You can, I've seen where you can create, like the initial one generally takes like a creation of the setup. Where I've seen it where you can create like a workspaces, like you create the workspaces workspace and then go back through and then apply it within Terraform Cloud and would create the other ones. But there's generally at one point you'll have to start at the command line. Okay.
Yeah, that makes sense. A lot of the examples that I've shown in the past where I build sort of those sequences where it's 0, 1, 2 for each of the sequences. 0 is always the local variety prior to any remote state existing.
Exactly. Now, I have logged into Terraform Cloud. And as you can see, there's now 3 different workspaces. You know, the data resources dev, data resources prod, data resources QA that I created within my local GitHub that I ran locally. And right now it's saying, it's kind of nice because it already kicked off a plan for me. And while it is complaining about my old uses of the old resources, there's a video talking about how to update that I probably should rewatch. But there is, as you can see, that this is creating, this is the workspace created, and it's showing it needs to, I want to create, I want to create the app services here. And then you can do a confirm and it does the apply. So now it's being managed within Terraform Cloud. And
as part of this, you created the service account, service principal that we'll use going forward to work with Azure or the Azure RM provider.
Yeah, exactly. And it created one resource so far. Let's wait for the other one. And I'll show the state. So this is not following like the traditional where you have like a storage account that holds the state file like on your local like AWS Azure instance. This is being stored within Terraform Cloud. It's encrypted, but you can still see it here if you need it. Here are all the variables that we went through. You know, I was telling you like here's created. This says sensitive, but probably within the state file it's there. So you still want to limit the access to Terraform Cloud to, you know, responsible people.
Okay, so you showed how we generate the workspace and then how the workspace included a subdirectory, and so it automatically ran that. So from an automation standpoint, that was pretty awesome because it just took care of everything in one pass. I also wanted to show another scenario where you'll see after you're working on code that's actually attached to the workspace, and you want to run code that is inside of Terraform, there's a couple things that I guess are happening here. So one of those is going to be that your provider information is going to change a little bit. So you'll notice in here that I changed from, in this case, it was a migration, right? I moved this code up to the cloud. So instead of running this code inside of Azure M, or running the state inside of Azure M, I put in this cloud setting, which points now to my Terraform Cloud workspaces. So once this is here, the whole CLI starts behaving differently. So if I were to do a plan, you can see right away how that differs. So you'll see right here, running plan in Terraform Cloud. And I think this is really awesome. So it's actually running it remotely, and I can connect to that remote run and watch the progress of it, or I can watch it right here in the comfort of my CLI. So if you're real familiar with the CLI, as I am, then it just feels good to be able to still run this plan step while I'm still working on things. I'm still in the early work of the process. And so it shows you, it run it all remotely, and it shows you the results of that plan. Now, if I then wanted to actually apply it, if I wanted to do a Terraform apply, then you'll see that this also changes a little bit. So if I run an apply step here, right away, it says that we're not allowed to do that. And that's because we're connected to this is GitOps, right? We're connected to a GitOps enabled method, I guess. Terraform Cloud in my configuration is pointed to a Git repository. And because of that, I can't directly run an apply. I have to basically update that Git repository, which Terraform Cloud will then download. And because of my settings right now, it'll just run it automatically. So that's some of the differences that you'll see when you operate a separate instance when you're pointing to the workspace. So I think that's probably worth seeing and acknowledging the differences there. Also, that it's really easy to migrate up to Terraform Cloud. So if you have code that you maintain locally and you want to then put it into enterprise or cloud, some minor changes will get you there. And there's a couple other things. You'll need to bring your var files basically into the interface of Terraform Cloud, where you can inject those values, environmental, whatever it might be, into your run. But the capabilities that you showed us here are really impressive. They're fast and powerful. I can assume some of you are now putting two and two together and wondering about the security of enabling developers with this. So enter Sentinel. Sentinel allows you to implement policy as code in the same way that Terraform allows them to implement infrastructure as code. Sentinel governance policies define rules that restrict the provisioning of resources in a variety of ways. Terraform enforces Sentinel policies between the plan and apply phases of a run, preventing out-of-policy infrastructure from being provisioned in the first place. So Sentinel is a great step to move into if you need that level of control, and it's probably worth a video in and of itself, because I know it can get quite complicated. Through all of this, some of my personal experiences, I've seen workspaces grow rampantly just on-prem. So I can imagine a scenario where you want to be more on top of keeping things fresh in the environment. I haven't created the code for it, but I suspect that there would be an easy way to implement this in a way that we're recording runtimes and tags for our resources, just as a time date stamp, and then using those date stamps to guide workspace deactivation or destruction based on some threshold. So you could put in some date math to figure out, if this time has passed, then I want to destroy it or deactivate it. And that using the resources that you showed us, where I can interact directly with the workspace itself. You might be able to do everything with that, for that matter, inside the TFE provider. But there's also an API that you could go to if you absolutely had to.
So Terraform is a great solution for complex projects. I actually really agree with your assertion that workspaces can grow out of control. It's I've had it where all of a sudden you have like 100 workspaces and you're trying to find the one that you need to edit. Uh, but Terraform Cloud is great for a solution if you want to create like more complex projects and allow for different services in different environments. It allows you to offload, manage state files and workspaces within your Terraform code. Then, like I said, the biggest example I have is I had a client where they, as part of the requirement that dev had to match the next level environment. So dev had to match QA, which then had to match production. And using like workspaces, that's very, very simple to do
Hmm.
because you're like, here's my 3 workspaces. All that's different is the environment name. Done.
Which is
So
one of the big value props for Terraform or infrastructure as code in general, right?
exactly.
I think Terraform Cloud sits in a position similar to other SaaS products. Enterprise brings a lot of great features to your IAC practice, and Cloud share most features with it. But all of the infrastructure and software management of Enterprise is left to the user, as I mentioned briefly before. There's some simple math to help you decide if Terraform Cloud is a better decision than the Terraform Enterprise, and when the threshold would be reached to move over to the Enterprise product. What's great about cloud is that you can dip your toes in for free and start seeing that value right away.
Exactly. Well, thank you, everybody. And if you have any questions, leave a comment and please subscribe.